Welcome students. In this module, we will study different concentrated milk products, that is sweetened condensed milk and evaporated milks. Various manufacturing aspects are covered in this module. In order to preserve the milk constituents in a concentrated form, condensed milk or concentrated milk is manufactured from whole milk or skim milk by evaporating part of water under vacuum. Its main purpose is to diminish the volume and to enhance the shelf life. But this form of milk still has a limited shelf life. Attempts to prolong the shelf life of this product have been made through the addition of sugar, which is known as sweetened condensed milk, or by heat processing, which is known as evaporated milk, to destroy the microorganisms. The evaporation of milk has been known for many years, even as early as in the year of 1200, when Marco Polo described the production of a paste-like milk concentrate in Mongolia. The present-day concept of preservation of milk by concentration and by application of heat had the beginning with the pioneering work of Frenchman Nicolas Appert around 1793 AD. Gail Borden of United States of America was first to commercially exploit the method of concentration of milk under vacuum. He was awarded US patent in the year 1856 for processing milk in a semi-fluid state after evaporating under vacuum. Commercial production of sweetened condensed milk by Gail Borden started in 1856. By 1858, Borden's milk, sold as Eagle brand, had gained a reputation for purity, durability and economy. In 1864, Gail Borden's New York Condensed Milk Company constructed the New York Milk Condensery in Brewster, New York. The basic principle of the process of sterilization by heat was introduced by Mr. John B. Meinberg, a native of Switzerland. John B. Meinberg migrated to United States, was awarded a patent in 1884 for a process of sterilization of milk by steam under pressure. In the year 1885, evaporated milk was manufactured on commercial scale in United States based on the patent of Meinberg. The condensed and dried milks are manufactured by the commercial plants as per the legal standards prescribed by Food Safety and Standard Act 2006 in India. As per FSSAI, evaporated milk means the product obtained by partial removal of water from milk of cow and or buffalo milk by heat or any other process which leads to a product of the same composition and characteristics. The fat and protein content of the milk may be adjusted by addition and or removal of milk constituents in such a way as not to alter the whey protein to casein ratio of milk being adjusted. It shall have pleasant taste and flavor, free from off flavor and rancidity. It shall be free from any substance foreign to milk. It may contain food additives permitted in these regulations, including Appendix A. It shall conform to the microbiological requirements prescribed in Appendix B. It shall conform to the following requirements. Friends, you can see the legal requirements prescribed by Food Safety and Standards Act 2006 for evaporated milk. As per legal standard, evaporated milk is classified into different products such as evaporated milk, evaporated partly skim milk, evaporated skim milk, and evaporated high-fat milk. The milk fat, milk solids, and milk protein requirements are presented in this table. Sweetened condensed milk. As per FSSAI, sweetened condensed milk means the product obtained by partial removal of water from milk of cow and or buffalo with the addition of sugar or a combination of sucrose with other sugars, or by any other process which leads to a product of the same composition and characteristics. The fat and or protein content of the milk may be adjusted by addition and or withdrawal of milk constituents in such a way as not to alter the whey protein to casein ratio of the milk being adjusted. It shall have pleasant taste and flavor, free from off flavor and rancidity. It shall be free from any substance foreign to milk. It may contain food additives permitted in these regulations, including Appendix A. It shall conform to the microbiological requirements prescribed in Appendix B. It shall conform to the following requirements. In the table, you can see the legal requirements prescribed by Food Safety and Standard Act 2006. The sweetened condensed milk is classified into 4 different categories such as sweetened condensed milk, sweetened condensed skim milk, sweetened condensed partly skim milk, and sweetened condensed high fat milk. The milk fat on mass by mass basis, milk solids, and milk protein in milk solid not fat is given in the table. The gross composition of different type of condensed milk is given in the table. Now let us discuss principle of evaporation. Evaporation is a unit operation which involves simultaneous heat and mass transfer. Evaporation means the removal of solvent as vapor from a solution or slurry under such conditions that no attempt is made to separate components of the vapor. In majority of evaporation processes, the solvent is water and latent heat of evaporation is supplied by condensing steam, and heat from the stream is transmitted to the solution indirectly through the metallic surfaces. The unit in which heat transfer takes place is called heating element or calandria. An effect is one or more bodies boiling at the same temperature. A multiple effect evaporator is one in which vapor from one effect is used as heating medium for another effect boiling at a lower pressure. Vacuum pan. This type of evaporator is employed in the majority of condenseries for the manufacture of condensed milk. Batch operating type evaporator is preferred when relatively small quantities of milk are to be handled in a batch operation for product like sweetened condensed milk. The pan is internally fitted with steam coils and the lower portion is steam jacketed. The operation is usually carried out at 54 to 63 degrees Celsius. The milk boils at this temperature owing to reduced pressure, that is 63.5 centimeter of mercury, which is maintained in the pan. A vacuum pump is used to maintain the vacuum in the pan. When the water vapor which rises from boiling milk inside the pan comes in contact with cold metal surface or cold spray of water in the condenser, it is condensed and carried off as water by means of pumps or other means. falling film evaporators. This type of evaporator consists of vertical tube bundles heated by condensing steam on the outside. The liquid to be evaporated is fed to the top of the tube and allowed to flow downwards. On the inside of the tubes, the liquid will flow downwards, forming a thin film from which the boiling or evaporation will take place because of the heat applied by the steam. The resulting vapor and concentrated liquid flow into a separator at the foot of evaporator. The vapor is drawn off from the top of the separator and liquid from the bottom by a pump. This type of evaporator is desirable from a product point of view as it offers a short holding time. As vapor from the evaporated milk contains almost all the applied energy, it is obvious to utilize this to evaporate more water by condensing the vapor. This is done by adding another calandria to the evaporator. This new calandria, the second effect, where the boiling temperature is lower, now works as condenser for the vapors from the first effect, and the energy in the vapor is thus utilized as it condenses. Multiple effects. In the first evaporation unit, steam is introduced and part of the water is evaporated from the milk. The steam condenses and vapor is separated from the concentrated milk. The vapor is used to evaporate water from the concentrated milk in the second effect, and likewise, the flows of milk and vapor are co-current. The number of effects varies from 3 to 7. Thus, great economies of operation may be made in large installations with multiple effect evaporator. The vapor coming from the last effect is condensed in a special condenser. The temperature of the water in the condenser determines the boiling temperature in the last effect. The boiling temperatures in the other effects are determined by the pressure drop of the vapor when being transported to the next effect. Separators. As the vapors generated from the evaporation are used as heating medium in the next calandria, any product must be separated, since it would otherwise contaminate the condensate and further represent a loss. The majority of the concentrate is discharged from the bottom of the calandria below the tube bundle. The separation is done in a separator with tangential vapor inlet connected to the calandria below the tube. To reduce space requirements, a new development has taken place with the design of the wrap-around separator. It is integrated into the base of the calandria. It has the same high efficiency as the classical separator with a low pressure drop. Students, let us now start with various manufacturing aspects of sweetened condensed milk. Sweetened condensed milks are milk products which can be obtained by the partial removal of water from milk with the addition of sugar or by any other process which leads to a product of the same composition and characteristics. It may sometimes contain added refined lactose, calcium chloride, citric acid, and sodium citrate, sodium salts of orthophosphoric acid and polyphosphoric acid, not exceeding 0.3% by weight of the finished product. Now let us discuss manufacture of sweetened condensed milk. Sweetened condensed milk is milk that is concentrated by evaporation, to which sucrose is added to form an almost saturated sugar solution, after which it is packed. The high sugar concentration is primarily responsible for the keeping quality of the product and for its fairly long shelf life, even after the can has been opened, although it then will eventually become moldy. Friends, the slide indicates different steps involved in the manufacture of sweetened condensed milk. The steps are discussed in detail in further slides. Receiving of milk. Raw milk received for the manufacture of condensed milk should be of good quality. This is important because the quality and marketability of final product depends upon the initial quality of raw milk. As far as possible, milk should be fresh, sweet, and should be free from off flavors. It should not have sediments. Filtration or clarification. Milk after weighing should be clarified and filtered to remove visible foreign matter. Simple filtration may remove suspended particles by straining process, while clarification removes the same by centrifugal separation. Standardization of milk. This is done to conform to the legal standards in the end product. The standardization of milk meant for condensed milk preparation is done with a view to bring the fat is to SNF ratio of 9:22 to establish the desired ratio between the added sugar and total milk solids, and to adjust the concentration of finished product to the desired percentage of total solids. Standardization of milk involves addition of sufficient quantity of cream or skim milk to ensure the resultant product has the correct fat is to SNF ratio to yield the final product of desired composition. Forewarming or preheating of milk. The standardized milk is forewarmed or pasteurized prior to condensing. Pathogens and potential spoilage organisms must be killed. Among the enzymes, milk lipase should primarily be inactivated because if present, it can cause severe rancidity. The heating intensity considerably affects viscosity and also age thickening and gelation of the product. So, the actual heat treatment must be adjusted to these properties. Forewarming also helps in dissolving the sugar which is added during the next stage of operation. Further evaporation takes place more rapidly if heated milk is fed into vacuum pan or evaporator during concentration. The temperature time of forewarming extends over a wide range, such as 82 to 93 degrees Celsius for 5 to 15 minutes or 116 to 149 degrees Celsius for 0.5 to 5 minutes. The modern trend is towards high temperature short time heating, such as 115 to 118 degrees Celsius without holding. Tubular heat exchangers are commonly used for forewarming or preheating. Either a double tube or cell and tube heat exchangers are preferred. Plate heat exchanger may also be used. Next processing step in manufacture of sweetened condensed milk is addition of sugar. Sugar is added to the milk for the purpose of preserving the condensed milk without resorting to sterilization by heat. This can simply be added to the original milk. The amount added can be adjusted readily and the sugar is pasteurized along with the milk. However, this procedure causes fairly extensive Maillard reactions during heating and evaporation, and above all, a faster age thickening. Alternatively, a concentrated sugar solution, which should be sufficiently heat treated to kill any osmophilic yeast, is added at the end of evaporation step. Amount of sugar to be added during manufacture of sweetened condensed milk. The quantity of sugar added to milk should be enough to preserve the milk. It has been recommended that a sugar ratio of 62.5% would protect the condensed milk from bacterial defects. Generally, sugar ratio of 62.5 to 64.5 is considered adequate to protect condensed milk against bacterial spoilage and to protect against causing sugar crystallization. Sugar ratio is the sugar in water concentration of condensed milk. The formula for percentage sugar ratio is percentage sugar in condensed milk divided by 100 minus percentage total milk solids in condensed milk into 100. Amount of sugar to be added to milk to get the desired percentage sugar in condensed milk. First, determine the ratio of concentration by dividing percent total milk solids in condensed milk by percent total milk solids in fresh milk. Then divide the percentage of sugar in condensed milk by ratio of concentration. These are the formulas for calculation of ratio of concentration, that is percentage total milk solids in condensed milk divided by percentage total milk solids in fresh milk. This will give us ratio of concentration. And to calculate sugar in milk, the following formula is used, that is percentage sugar in condensed milk divided by the ratio of concentration. Condensing. Sweetened condensed milk is concentrated to a greater degree than is the case with the unsweetened variety. Concentration for manufacture of sweetened condensed milk is usually done by evaporation. The low water content of sweetened condensed milk implies a high viscosity and boiling point. Evaporation in continuously operating equipment with many effect is therefore not easy. Fouling thus readily occurs. It is difficult to accurately adjust the desired water content, which is mostly monitored by means of refractive index. Now, how to decide the end point of sweetened condensed milk manufacturing? The term striking of batch is used to decide the end of processing. The striking of batch refers to the end of concentration operation in the vacuum pan as determined by specific gravity or density test. The precise point at which the batch should be struck depends largely upon the experience of vacuum pan operators. Samples are taken at regular intervals by means of sampling cocks. Bombay hydrometer or a viscosity meter is used to determine the process and thus the progress of concentration. Bombay hydrometer test is most commonly used for density test of vacuum pan samples. The hydrometer scale may record the density either directly or indirectly. For condensed milk, the Bombay hydrometer ranges from 30 to 37 degree Bombay at 49 degrees Celsius. When the desired concentration as indicated by Bombay reading 32 degree Bombay is reached, the batch of milk is ready for removal from the pan. This operation is called striking the batch. The steam is shut off, the vacuum broken, and the milk run off to cooling tank. The batch after striking sometimes require final standardization. The fat SNF and added sugar are already present in their desired ratio to each other. The third and final standardization, therefore, has to do only with the adjustment of percentage of total solids, if such adjustment is necessary or desired. The sweetened condensed milk after final standardization requires cooling. Cooling of condensed milk is essential to control the texture of condensed milk. It is absolutely essential to cool the product promptly to desired temperature because in these steps, formation of large lactose crystals must be avoided. As the condensed milk is cooled, lactose, which is less soluble than sugar, crystallizes out, and if the lactose crystals are small enough, these crystals will not be detected, but if they are too large, they will impart sandy texture to the condensed milk. To avoid this defect, it is necessary to create conditions favorable for maximum crystallization of lactose. Consequently, seed lactose is added. Before that, the condensed milk must be cooled to a temperature at which lactose is supersaturated so that the seed lactose does not dissolve. Crystallization. The purpose of this is to produce mass crystallization of lactose. It is the period in the cooling process when sweetened condensed milk reaches a temperature which is most favorable for rapid crystallization of lactose. The relative smoothness of product depends upon number and size of crystals present. Our main aim is not to prevent the formation of crystals, but our main aim is to form more crystals having smaller size. For sweetened condensed milk of average composition, the temperature of maximum rapidity of crystallization is around 30 degrees Celsius. Seeding. Crystallization of lactose is usually assisted by the addition of fine powder of lactose or small quantity of condensed milk from previous batch in which the lactose crystals are in minute form. Lactose should be of smallest possible size, preferably 200 mass, that is less than 10 micron, having sharp crystal edges. To avoid contamination of product, the lactose used for seeding should be sterilized under vacuum at 93 degrees Celsius, which will convert lactose hydrate to anhydrate. Then it is ground to fine particles in a perfect pulverizer, filling in the can and sealing it. Then sealed can is sterilized at 130 degrees Celsius for 1 to 2 hours. Other alternative is to use spray dried skim milk powder as seed material. Seeding refers to the introduction of lactose in a very fine powder form during cooling process to provide nuclei for crystallization. The purpose is to give lactose present in the supersaturated state an added incentive to crystallize. Seeding at an optimum temperature for mass crystallization with properly prepared lactose and with vigorous agitation yields large number of small crystals of uniform size. The recommended amount of finally pulverized lactose for seeding purpose is 375 to 500 grams per 1000 kg of initial milk taken or 0.1 to 0.3% of condensed milk. The usual seeding temperature is 27 to 39 degrees Celsius for cow's milk, and for buffalo milk it ranges from 30 to 36 degrees Celsius. After crystallization is over, lower down the temperature to room temperature. This cooling is done by several methods. After cooling, it is again stirred for 20 minutes because due to lower temperature, solubility decreases and there is possibility of crystallization. Packaging of sweetened condensed milk. Packaging of sweetened condensed milk in cans is quite common. The cans are then covered with a lid and the seams are sealed. Cans and lids are first sterilized. The packaging room is supplied with air purified through bacterial filters. Sweetened condensed milk reaches the market in the form of bulk good and also in different size retail packs. Dear students, Till now we have discussed about manufacturing steps involved in manufacture of sweetened condensed milk. Now let us start with evaporated milk. Evaporated milk is sterilized, concentrated, homogenized milk. The product can be kept without refrigeration and has a longer shelf life. It is completely safe for the user. In this product, no sugar is added as preservative. To achieve preservation, the product is sterilized by heat after concentration and sold in the hermetically sealed container in which it has been sterilized. A major problem with sterilization is heat stability. The higher the concentration of the milk, the lower is the stability. Various steps involved in the manufacture of evaporated milk are depicted in the figure. These steps are discussed in detail in the following slides. The first step in manufacture of evaporated milk is receiving of milk, filtration of milk, or maybe the milk can be clarified. The raw milk used in preparation of evaporated milk is treated in a similar manner to that which applies in case of sweetened condensed milk as discussed earlier during manufacture of sweetened condensed milk. Variation of the quality of the milk has a direct effect on heat stability of evaporated milk and thus indirectly also influences the viscosity of the finished product. Standardization of fat to SNF ratio. The milk that has passed inspection is then dumped into the weighing tanks, and after sampling and recording weights, it is dropped into supply tank from which it is pumped over or through a cooler into holding tanks. There it is tested for fat and total solids and standardized to the ratio of fat to SNF desired in the evaporated milk. Forewarming of milk for evaporated milk. Preheating serves to enhance the heat stability of the evaporated milk, inactivate enzymes, and kill microorganisms, including a significant proportion of the bacterial spores present. Here, the destruction of biological agents injurious to health or damaging to keeping quality that might be present in raw milk is the function of the process of sterilization by steam under pressure. However, aside from these, the forewarming is indispensable for satisfactory vacuum pan operation also. Temperature of forewarming. The heating temperature time relationship is usually selected on the basis of heat stability. Formerly, a long heat treatment, that is for 20 minutes at a temperature below 100 degrees Celsius, was often applied. Currently, UHT treatment is generally preferred. It reduces the number of spores in the milk considerably and therefore a less intensive sterilization suffices. Condensing of evaporated milk. The forewarm milk is condensed to desired concentration in the vacuum pan or evaporator in a similar manner as done in the case of sweetened condensed milk. Evaporated milk boils at somewhat more vigorously and needs somewhat closer watching because of absence of stabilizing influence of sugar. Ratio of concentration. On the basis of fluid milk with an average total solids content of 12.25%, the ratio of concentration of evaporated milk is applied as follows. As per FSSA standards, evaporated milk should have 26% total milk solid. So 26% is divided by percentage total solid content of milk, that is 12.25%, yields a ratio of concentration of 2.1224 is to 1. Striking the batch. The striking or sampling and testing for density of evaporated milk is more easily accomplished than that of viscous syrup of sweetened condensed milk. When evaporated milk approaches the desired concentration, its consistency resembles that of rich milk or thin cream. Its fluidity therefore ensures ready equilibrium of the hydrometer. The Bombay hydrometer, with a scale of range from 0 to 15 degree Bombay subdivided into 1/10 degrees, is commonly used for the testing the pan sample. Establishment of standard striking temperature helps to avoid misleading results. A convenient temperature is the pan temperature, which near the finish of the batch usually ranges from approximately 48.9 to 54.4 degrees Celsius. Homogenization. Homogenization serves to prevent creaming and coalescence during storage. It should not be too intensive because the heat stability becomes too low. Product should be homogenized at 49 degrees Celsius or above to avoid fat clumping and action of lipase enzyme. Two-stage homogenizer is advisable at first stage 140 to 175 kg per centimeter square and at second stage 35 kg per centimeter square. Cooling of evaporated milk. After homogenization, concentrated milk is cooled to 5 degrees Celsius and held in storage tank. Stabilizing salts may be added to concentrated milk in tank as indicated by pilot sterilization test. To ensure that evaporated homogenized milk does not coagulate during sterilization and at the same time does acquire a desirable viscosity, a series of sterilization tests is often done on small quantities of the evaporated milk, to which varying amounts of stabilizing salts are added. The tests are needed because variation occurs among batches of milk. Essentially, the addition of the salt means adjusting the pH, because further processing must be postponed until the test results are available. This necessitates cooling the evaporated milk after its homogenization and storing it for a while. Now let us discuss what is pilot sterilization test. The purpose is to determine the amount and type of chemical stabilizers to be added to any given batch of condensed milk for most satisfactory heat stability. Heat coagulation of milk is influenced by many factors such as initial quality of raw milk, forewarming temperature, concentration and sterilization. In raw milk, it has been suggested that salt balance of milk, that is ratio of calcium plus magnesium to citrate plus phosphate, is important for the stability of milk towards heat. If the ratio is disturbed, the heat stability may be affected. Depending on the location of pH of maximum stability with respect to natural pH of concentrated milk, either sodium salt or orthophosphate or calcium chloride or monosodium phosphate are used as stabilizers. This is the basis of a process of pilot sterilization in which various quantities of selected stabilizers are added to the concentrated milk in 170 ml tins, which are then sterilized and condition of the product carefully examined in order to determine whether any stabilizer is necessary and if so, in what amount it should be used. Depending upon the type of milk and the processing condition used, 100 to 300 gram of stabilizing salts per 100 kg of evaporated milk may be needed to improve the heat stability. Calculated amount of salt is added to the evaporated milk in the form of solution using just enough water to dissolve it. Canning process. Packaging in cans is common. Evaporated milk intended for use in coffee is usually packaged in bottles that are closed with a crown cork or a screw cap. can should meet all the sanitary standards and its metal should be non-toxic to the product or should not impart any flavor in it. The evaporated milk container must withstand the pressure changes in the process of sterilization. Its seal must be absolutely airtight and it must be strong. Sterilization of evaporated milk cans. In bottle or in can sterilization can be applied batch-wise in an autoclave at 115 degrees Celsius for 15 to 20 minutes, or it can be achieved by continuous method such as UHT processing with a time temperature combination of 135 degrees Celsius for 1 to 3 seconds. The sterilized milk cans are stored after sterilization process. Storage. After sterilization, cans of evaporated milk are unloaded from sterilizer and cooled by water spray. As evaporated milk is sterilized product, it may be stored at or below room temperature. So friends, in this entire module, we have studied various manufacturing aspects involved in manufacture of sweetened condensed milk and evaporated milk. Thank you.